A body of mass 10 kg is moving with an initial speed of 20 meter per second. The body stops after 5 seconds due to the friction between body and the floor. The value of the friction is okay. So as usual, let us try to understand what should be the flow chart here. So we have a frame of reference, right? Well, ideally we should start with visualizing the given data, right? Visualizing and then choosing the frame of reference. So I have drawn a diagram to visualize things here. A body of mass 10 kilogram. Maybe I'll just enlarge it. Yeah. So a body of mass 10 kilogram moving with speed of 20 meter per second. The body stops after 5 seconds. So the body is moving like this after t is equal to 5 seconds. The body stops, which means the final velocity here is equal to 0. So the moment we have this scenario, we can choose a frame of reference, which usually I prefer to choose non-inertial frame, right? So this is a person watching things from outside the system. Now, by velocity time relationship, we have v is equal to u plus at. Final velocity is 0, initial velocity is 20. A is not given, time is given to us as 5 seconds. Therefore, we can say that A is minus 20, 5A is equal to minus 20, and therefore what would the value of A? A would therefore be equal to minus 4, right? Now let us go to the selecting the body, which is this body. So we have the body here, and draw the various forces acting on it. The first force would be force of gravitation, which would result in weight, mg acting downwards. Now, since the body is exerting and force downwards, being in contact with the floor, right? Being in contact with the floor, the body will receive an opposite force from the floor, which we call as normal reaction. So we have normal reaction on the block arising from the floor, right? And since it is moving towards the right, the net direction of motion is towards the right. And since the motion is towards the right, we know that friction will act if the body is moving towards the right. If the body is moving towards the right, then friction will be acting towards the left. But now the question comes up, although not mentioned in the in this given problem. The question here is, what kind of friction is this? Is this static friction or is this kinetic friction? Well, we need to understand the concept here. See, static friction and okay, I think let's do one thing. Let's wait for one more question. Maybe I'll just I'll detail the concept here. Here, what we need to understand is the friction is kinetic friction, and we'll in the next question we'll see how to detail how to differentiate both of them. Not here. So this is anyway kinetic friction here. The body is moving. This is kinetic friction. Now, if we apply sigma fx and sigma fy, sigma fx is equal to ma and sigma fy is equal to 0. Why? Because body is not moving in the which direction? Body is not moving in the y direction. Therefore, there is no motion in the y direction, and therefore vy is equal to 0. Therefore, ay is equal to 0, and m into ay is equal to 0, which implies fy is equal to 0. Okay. So yeah, that's it. But there is motion in the x direction, and therefore sigma fx should be equal to ma. What is sigma fx? Sum of all the forces acting in the x direction. How many forces are there in the x direction here? If you observe the free body diagram, there is only one force, a retarding force, which is kf. And how will you choose the sign convention? All those forces which are acting along the direction, net direction of motion, would be taken as positive. All the forces acting against the net direction of motion would be taken as negative, and therefore we'll take minus kf is equal to ma. And what is the value of kf? Kinetic friction. Kinetic friction is given to us as okay, it's not given. We need to find the value of friction. Okay, so what is the formula for kinetic friction? It is mu. My bad. This is not mu s. This should be mu k. This should be mu k. So what is mu k into n? Mu k into n is equal to ma. What is mu k into n is equal to, what is n here? N from this equation, what is sigma y is equal to sigma fy is equal to 0 implies all the forces acting in the up direction should be equal to all the forces acting in the down direction. So sigma fy is equal to 0 implies sigma of forces acting in the up direction would be equal to sigma of forces acting in the down direction. What are the forces acting in the up direction? The only force acting in the up direction is normal reaction. What are the forces acting in the down direction? The only force acting in the down direction is mg, and therefore we have normal reaction is equal to mg. So instead of n here, what can we write? We can now write m into g. So from here I can cancel out m, and then what we have is minus mu k into g, which is 10, is equal to a, right? What is the value of a? A we found to be minus 4, therefore what is mu k is equal to? Mu k would therefore be equal to, let's cancel out minus and minus, so we have 4 by 10, which is equal to 0.4. So the correct option here would be, the value of friction is 0.4.